In this video, we're going to look at the concept of probability, and we're also going to look at the concept of what's called odds. So we're going to look at probability and odds and the probability or odds that an event will occur, and we're also going to look at something called the counting principle that helps us look at probability of an event occurring in a different way. So before we dive into probability, we want to look at 3 important vocabulary words that you need to know in order to understand probability. So the first word you want to have in your notebook is this word outcomes. And outcomes are all of the possible results of an experiment. So for example, say that we roll a dice. The outcomes of rolling the dice are, if it's a normal 6-sided dice, are 1, 2, 3, 4, 5, or 6. One of these 6 things is going to happen when we roll a dice. So the outcome are the possible results that could happen. In this case, 1, 2, 3, 4, 5, and 6. The second word you want to have in your notebook is an event. And an event is an outcome or a collection of outcomes. So for example, if you are still rolling this dice up here, an event, something that occurs, could be rolling a 6. That's an event. We can roll a 6. Or it can be a collection of outcomes together, such as rolling an odd number, which, remember, an odd number will be 1, 3, or 5. And then from there, our third vocabulary term that you want to have in your notebook is favorable outcome. So a favorable outcome is an outcome for the event that is specified. So for example, a favorable outcome, if we say our event is that we want to roll an odd number. If we want to roll an odd number, if that is our event, the favorable outcomes that result in that happening are 1, 3, and 5. So now that we understand those 3 vocab terms, we can now look at the definition of probability. And the probability of an event is given by the fraction that you see right here. So here it says P. This P here stands for probability. And what this statement on the left is saying is the probability of an event occurring. And when we have a probability that we're calculating, we're going to find 2 values. We're going to figure out what the number of favorable outcomes are, and then we're going to figure out the total number of outcomes. And our probability fraction is formed by taking the total number of favorable outcomes and dividing it by the total number of all of the outcomes. So let's try to apply this to our example right here. Our example here says, suppose you roll a normal 6-sided dice. So that's what we're doing. We're rolling a dice. What is the probability that you roll an even number? So we are trying to find the probability, there's the P, of an even number. Now, in order to form this fraction, we need the total number of favorable outcomes. Well, if I'm rolling a 6-sided dice, so I'm going to do favorable outcomes here. If I'm rolling a 6-sided dice, even numbers that I could roll are 2, 4, and 6. So as a result of this, I have 3 favorable outcomes. As a result, this is going to go in the numerator of my fraction, which is 3. I then need my total number of outcomes for my denominator. Well, my total number of outcomes is 1, 2, 3, 4, 5, and 6. I have 6 different options for a total of 6 in my denominator. So here I have the probability of an even number being rolled is 3 over 6. But that's not in simplest form, and we know that we need to simplify fractions. So if I divide each of these by 3, I get probability of 1/2. So the probability that I roll an even number is a probability of 1/2. So in order to do some more probability practice, we're going to use a deck of cards. And what I've realized in my years of teaching is that students do not always know how a deck of cards is set up. So what we're going to do first is we're going to talk about how a deck of cards is set up, and then we're going to use it to solve some probability problems. And I like to use a deck of cards just because there's a lot of different combinations that you can come up with a deck of cards. So to start off, the first thing you need to know is that a deck of cards has a total of 52 cards. So 52 will always be our total number of possible outcomes because there are 52 cards. Then from here, our 52 cards splits into two groups. We split into a red group and we split into a black group. So we split it directly in half. So we have 26 red cards. And then we have 26 black cards. So that deck of cards is essentially split in half, 26 red and 26 black. Then from here, our cards actually split a little bit further. So in the red cards, there are two different types of suits. There are 13 hearts, and there are 13 diamonds. So we have 13 hearts and 13 diamonds. In the black cards, we actually have 13 spades, which I'm kind of bad at drawing, but we'll go with that. So these are called spades. And then I have 13 clubs. So we have hearts, diamonds, spades, and clubs. Now, if you aren't familiar with the deck of cards, these are called your different suits. So we have 4 different suits of cards. So we have 52 cards. They then split in half, with half of them, 26 being red, half 26 being black. And then within each of those colors, we have 2 different suits. We have 13 hearts, 13 diamonds, 13 spades, and 13 clubs. Then each suit has the following. We have an ace, which is kind of like a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we have a jack, a queen, and a king. So each one of those 13 cards are essentially made up of 1 through 10 plus a jack, a queen, and a king. So we have hearts have an ace of hearts, a 2 of hearts, a 3 of hearts, a 4 of hearts, so on and so forth. Diamonds have the same thing. We have an ace of diamonds, a 2 of diamonds, a 3 of diamonds, and a 4 of diamonds. Spades have the same thing, as do the clubs. So we're going to use this knowledge as we do some probability problems on the next page. So hopefully you took some notes on those decks of cards, and now we're going to use that knowledge that we just acquired to do some probability practice. So remember, probability of an event is the number of favorable outcomes over the total. That's how we calculate the probability of our event. So the first one says, what is the probability that you pick a red card? So, probability of red. If I think back, I remember that half of the cards in my deck were red, so I have a total of 52 cards, which means I have 26 red cards. Remember, red is my favorable outcome here, so there are 26 red cards. So we have our number of favorable up here, and then we're going to divide it by our total number, which is 52. So now from here I can see my fraction is 26 over 52. I want to simplify those, so I'm going to start by dividing them by 2 each. If I divide them each by 2, I end up with a fraction of 13 over 26. I can then see both of those are divisible by 13, which then I end up with probability of red is equal to 1/2, which makes sense because half of those cards are red. Okay, next example. It says, what is the probability that you pick a king? So the probability of a king. So again, I need favorable over total. Well, I know my total is 52. Then I have to think about how many kings are in a deck of cards. Well, I know that there's a king of hearts, a king of diamonds, a king of clubs, and a king of spades. Ignore my spade. My spade was kind of bad. So I have 4 different suits, which means I have 4 total kings. So my probability is 4, my favorable outcomes, over my total, which is 52. Now I can see that both of these are divisible by 2, so I'm going to simplify this fraction divided by 2. I then end up with 2 over 26, which again, they're both divisible by 2. So I end up with the probability of a king being equal to 1 over 13. Okay, next one. So what is the probability that you pick a heart? So probability of a heart. Remember, I need favorable over unfavorable. Well, there are 4 suits. And I remember that there are 13 cards in each suit. There are 13 total hearts. So that means my favorable is 13 over my total, which is 52. I can see that each of those is divisible by 13. So I end up with the probability that I pick a heart to be 1 over 4. All right, the next one says, what is the probability that you pick an odd number? So this one's actually a little bit trickier. So the probability of picking an odd number. So I know my total is 52. And then I have to think through odd numbers. What odd numbers are there? Well, the ace technically isn't an odd number because it has an A on it. So odd numbers would consist of 3, 5, 7, and 9. Those are my cards that might, by chance, have an odd number on them. Now I know that I'm going to have these numbers for hearts, for diamonds, for clubs, and for spades. They're going to have one of those cards for each suit. So I can see I have a total of 16 cards in my entire deck that might have an odd number on them. So my probability is 16 over 52. Now I can see that each of these are even numbers, so I'm going to divide them by 2. That gets me 8 over 26, which again are 2 even numbers. So I divide those by 2 again. And I end up with the probability that I pick an odd number to be 4 over 13. All right, and the last one here, I want the probability that I pick a red queen. So total goes in my denominator, that's 52. I then need to figure out how many red queens there are. So I have to think through, okay, what suits are red? Well, I remember that diamonds and hearts are both red. The other 2 suits are black, and each of these will have 1 queen. So I have a total of 2 red queens in my entire deck. Then I can see these are both even numbers, so I'm going to simplify them. And I find that the probability that I have a red queen that I've picked out of my deck at random would be 1 over 26. So now we're going to take this idea of probability and kind of put it in some more real-world examples beyond a deck of cards. So this example says a mini golf course offers a free game to people who get a hole-in-one on the last hole. Last week, 44 out of 256 golfers got a hole-in-one. Find the probability that you make a hole-in-one on the last hole. So remember here, we're taking the favorable outcomes over the total outcomes. So total last week in our denominator, we had 256 golfers. Then in our numerator, we want to have the favorable outcomes. Well, favorable is making a hole-in-one, and last week 44 people did that. So that's our probability fraction. Now, because we are good mathematicians, we're always simplifying. So I can see that both of these are divisible by 2 just because they're even. So I get 22 over 128. Those are still even, so I divide by 2 a little bit more. And then I end up with 11 over 64. So the probability that I hit a hole-in-one next week when I'm out golfing is 11 over 64. All right, example 2, it says you interviewed 45 students randomly chosen for the newspaper. Of those students, 15 play sports. What is the probability of the next student you choose playing sports? So we have a probability of playing sports. We then need favorable outcomes over total outcomes. So favorable that they play sports is these 15 students right here. And total is 45 students that have been interviewed. So then from here, all we need to do is simplify. I know both of these are divisible by 15. And as a result, I get a probability of 1/3 that the next person I pick will play sports. Now, probability is all fine and dandy, but really, truly, we need to know how to interpret our probability. So what we're going to do next is we're going to look at situations and their probability, and then we're going to interpret it and see if that event is impossible, unlikely, occurs half the time, likely, or is certain to occur. So this first one here says the probability of rolling an even number, and we're going to assume that we have a regular 6-sided dice. So the probability of rolling an even number, remember even numbers on our dice are 2, 4, and 6. So there are 3 favorable outcomes and there are 6 total outcomes. So there's our probability statement there. Now we can simplify this a little bit. And we know our probability is 1 over 2. Now, we want to actually be able to interpret this. So to interpret this, you're going to need your calculator, and you're going to need to divide 1 by 2. So take 1 divided by 2 in your calculator, and you get a decimal of 0.5. Now, this decimal is what we're going to compare to our scale up here. So our scale up here is telling us how to interpret our probability. And what I'm noticing is that this one falls right here in the middle. And as a result, I expect to roll an even number about half of the time, which, using my knowledge of dice, that makes sense to my brain. So there's our first one. The second one says the probability of rolling a 7. Well, our total number of favorable outcomes, there aren't any. We can't roll a 7 on a regular 6-sided dice. They go from 1 to 6. So as a result, our total number of favorable outcomes is 0. And our total number of outcomes is 6. Then from here, if we divide 0 by 6, so I take my calculator, 0 divided by 6, that gives me 0. And what this particular statement tells me, and I'll use a different color here, this statement is telling me that this event is impossible. It won't ever occur, which makes sense given the fact that I'm going to try to roll a 7 on a 6-sided dice. Okay, the next one says the probability of rolling a number that is less than 10. So, the total number of outcomes in my denominator is still 6. Probability of rolling a number less than 10. Well, every single number on that dice, 1, 2, 3, 4, 5, and 6, are all less than 10. So number of favorable outcomes is 6. So now if I take my calculator and divide 6 by 6, I end up with 1. And what this is telling me, if I interpret my probability, is that this event is certain to occur. I am certain to roll a number that is less than 10 because all of the numbers on the dice are less than 10. Now, this last one here says the probability of rolling a number 1 through 5. So our number of favorable outcomes is 5 because we could roll a 1, 2, 3, 4, or 5. Then my total number of outcomes is 6 because there are 6 numbers on that dice. So now if I divide 5 by 6, I end up with 0.833 repeating. So here, if I go and try to interpret my probability, this is landing about right here. So what this particular situation is telling me is that this event is likely to occur. I am likely to roll a number from 1 to 5 when I roll that dice, which makes sense because most of the numbers are from 1 to 5 and only one number represents something that is not 5. So now that we've mastered probability, we're now going to look at odds. And odds is something that a lot of people are not familiar with and do not understand. Odds a lot of the time are what you see on a lottery ticket, or if you go to like a horse track. They might also be at the casino. So if you're going to do any sort of gambling in your future, you want to make sure that you understand odds, because odds is different from probability and they look very similar. So here, if we look at our definition of odds, we see that the odds that an event is taking place is a fraction, just like probability. And it has the number of favorable outcomes here in the numerator. So odds and probability actually share a numerator. Where they differ is in their denominator. So here you can see our denominator is no longer the total, but it's the number of unfavorable outcomes. So we need to be careful as we calculate that. Unfavorable outcomes means that the event is not going to occur. So let's look at this example here. It says, what are the odds that we roll a 4? So here my fraction is favorable in the numerator. So if I'm rolling a normal 6-sided dice, the number of favorable outcomes is 1 because my options are 1, 2, 3, 4, 5, and 6. And if I want to roll a 4, that's my favorable outcome. Now, my denominator in this case is no longer the total. In odds, my denominator is actually the number of unfavorable outcomes, which if we look here in this list of 6, we have 1, 2, 3, 4, 5 numbers that are unfavorable outcomes. So our denominator here is going to be 5. So notice the slight differences between odds and probability. Probability is favorable over total. Odds is favorable over unfavorable. So now if we look at the next one. So it says, what are the odds that we roll in even number? So again, if we think about all of the outcomes, 1 through 6, that should be a 5 and 6. So the odds that we roll an even number in our numerator needs to be the favorable outcomes. So we have 1, 2, 3 favorable outcomes of 2, 4, and 6. Now my unfavorable outcomes, I have 1, 2, 3 of those as well. 1, 3, and 5. So this looks a little bit different than the probability one. Our odds of rolling an even are 3 over 3, or 3 to 3. Now we can simplify this a little bit, and we get odds of 1 over 1. So this is why we typically say the odds are blank to blank. We're saying the odds are favorable to unfavorable. And then this last example here, so it says, what are the odds of choosing a 2 or a 3? So again, we have favorable in our numerator. So if we think about all of the options for rolling our dice, we can see that there are 2, 3, and 2 that are favorable. Then from here, we can see that we have 4 numbers, 1, 2, 3, 4, that are unfavorable. So we have favorable over unfavorable, then we simplify, and we get the odds of rolling a 2 or 3 are odds of 1 to 2. So just to quickly summarize what we've just learned, probability and odds, they are similar in the fact that they both have a fraction. They both also have the number of favorable outcomes in their numerator. Where probability and odds differ and where we have to be careful when we read is what goes in the denominator. The denominator for probability is the total number of outcomes. In odds, our denominator is the number of unfavorable outcomes. So as we tackle the next slide, remember these slight differences between probability and odds. So now let's mix these concepts together using our deck of cards and see if we can do probability and odds and really slow down and distinguish when we need to use which. So if we look at this first example here, it says, what is the probability that you select a king or a queen from your deck of cards? So remember, probability is the number of favorable over the total. So we do a probability of a king or a queen. And in probability, my denominator needs the total. So I have 52 cards as my total number of outcomes. Now, in my deck of cards, to find my favorable number, I need to think about kings and queens. Remember, there are 4 suits, and there's 1 king and 1 queen in each suit. So we, as a result, have 4 kings and 4 queens, 1 of each suit, for a total of 8 favorable outcomes. So here we have 8 favorable outcomes. Now I can simplify these. They're each divisible by 4. So I end up with a probability of choosing a king or a queen of 2 over 13. So now if I look at the next problem, it says, what are the odds? So notice this one is different. It says, what are the odds that you select a diamond? Well, I know diamonds are one of the 4 suits, and I know that there are 13 diamonds in my deck of cards. We're going to do the odds that we select a diamond card. Now, I know that my numerator in odds is the number of favorable outcomes. We can see that up here. So favorable outcomes, there are 13 cards that could be a diamond. So those are my favorable outcomes. Now, where this gets tricky is in figuring out what my unfavorable outcomes are going to be. So my denominator here is not going to be 52 because it is not the total. I need my number of unfavorable outcomes here. Now, it might seem like that's a little tricky. We have to count all the rest of the cards, or we can take our total of 52, subtract out those favorable outcomes, and we're left with 39 unfavorable outcomes. 39 times where we would not pick a diamond. So we would put 39 there. And now from here we can simplify. Both of these are divisible by 13. So we end up with the odds of picking a diamond as the odds of 1 to 3. So now if we look at the next problem, the next one asks us to find the odds that we choose a 6. So we're doing odds again. So we're doing favorable outcomes over unfavorable outcomes. So odds that we choose a 6. So now favorable needs to go in my numerator, and I know that there are 4 suits in my deck, each one with 1 6. So there are 4 6s in my deck. So I have favorable outcomes is 4 because I have my 4 6s. Now, because this is odds, I need my unfavorable outcomes, not my total. So I take my total of 52, subtract out the 4 favorable outcomes, and I end up with 48 unfavorable outcomes. Now from here, I need to simplify. Each of these are divisible by 4. So we end up with 1 over 12. So the odds of picking a 6 are 1 to 12. Now, if we look at this next one, it says the probability that you choose a number from 1 to 5. Now, 1 is our ace card, so we'll count that as our ace card. So we want probability that we choose a number from 1 to 5. So we need our number of favorable outcomes in our numerator. So if we think these through, we have 4 aces, 4 twos, 4 threes, 4 fours, and 4 fives in our deck. We have 4 of each of those, 1 in each suit. So if I add up these 4s in purple together, I discovered that I have 20 favorable outcomes. Now in probability, we have number of favorable over total. So my denominator is my total number of outcomes, which is 52. Then from here, I note that each of these are divisible by 4, so I can simplify this down to be 5 over 13. Now if I look at the next one, what are the odds that you select a black jack? So odds that I select a black jack. Remember that my fraction consists of favorable outcomes over unfavorable outcomes. We can see that by looking up here. So if I think about black jacks, I know that I'm going to have a jack of spades that is black and a jack of clubs that is black. And as a result, I'm going to have 2 black jacks. So my number of favorable outcomes is 2. Then my denominator is my unfavorable outcomes, which in this case, if I take 52, my total, minus the 2 favorable, I end up with 50 unfavorable outcomes. Now each of these is divisible by 2, so I simplify that down to have odds of choosing a black jack be 1 to 25. And lastly, we need to calculate the probability that you choose a red queen. So probability that we choose a red queen. Now if we look back at the top, we know probability is number of favorable over the total. So my total goes in my denominator, which is 52. My number of favorable, I know that I have a red queen that I need to find. So I have a queen of hearts and a queen of diamonds. So I have 2 red queens in my deck. I then simplify this fraction, and we end up with a probability of choosing a red queen of 1 over 26. So you have to be careful on these. You have to note, do I have probability or do I have odds, and note how they are different. So the last thing we're going to look at here is something called the counting principle. And this is a way to figure out the total number of outcomes that you have given a situation. And to learn it, we're just going to dive right in and think about it, because that's really the best way to really begin to understand the counting principle. So it says, in your closet at home, you have 3 pairs of pants. So let's say our 3 pairs of pants are jeans, or khakis, or sweatpants. So we have sweats. Then we also have 5 shirts. So let's say that our shirts are blue, yellow, green, pink, and red. And it says, how many different outfits can you design using these clothing items? So I like to make a tree diagram to describe this the first time so we can see it in action. But this is me. And in our closet at home, we have 3 pairs of pants. So we're going to choose, okay, one of 3 pairs of pants. So here's my jeans. Here's my khakis. And here's my sweatpants. And then from here, I can pair up each of my pairs of pants, or each of my types of pants, with my 5 different shirt options. So, for example, I could wear jeans with a blue shirt, jeans with a yellow shirt, jeans with a green shirt, jeans with a pink shirt, or jeans with a red shirt. And then I can go to my khakis, and I can wear khakis with a blue shirt, khakis with a yellow shirt, khakis with a green shirt, khakis with a pink shirt, or khakis with a red shirt. And then my sweatpants I can wear with a blue shirt, a yellow, a green, a pink, and a red. So what I can see here in this tree diagram are all of the different outfits that I can make using these different clothing items. So here is option 1, option 2, option 3, option 4, and option 5. 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So we have 15 different outfits that we can make out of these 8 items that we have. Now, what a lot of students start to pick up on right off the bat is they look at the beginning and they say, well, I noticed that I have 15 different outfits and that I have 3 pairs of pants and 5 shirts, and if I take 3 times 5, that will give me my 15 different outfits. And that's exactly correct. So what we're going to do on the next slides is we're going to talk about this counting principle and a shortcut that we can use so we don't have to draw out this tree diagram every time unless we really want to. So the definition of the counting principle says if an event occurs in m ways, so we had an event occur, this was our number of pants in the last example, and a second event can occur in n ways, so this would be our shirts, number of shirts. Then the number of ways the 2 events can occur together, hence our outfits, can be calculated by taking m times n. So the number of possible outcomes of event 1 times the number of possible outcomes of event 2. So we have 3 pants times 5 shirts, which gave us 15 outfits. And we're going to use this to help us calculate the number of outcomes in similar situations on the next slide. So in her pantry, Sophia has 3 different options for soup, 2 different options for crackers, and 4 different options for desserts. How many different soup, cracker, and dessert combinations can Sophia make? So if I'm looking through here, what I'm noticing is I have 3 different events or 3 different option sets. I have soup, cracker, and dessert combination. So I have soup, cracker, and dessert. And I want to figure out how many different combinations I can have. Now, using the counting principle, all I need to do is multiply these together. So I have 3 different options for soup times 2 different options for crackers times 3 different options for desserts. So 3 times 2 is 6, times 3 more is 18 total combinations. So that's how many different combinations of soup, cracker, and desserts I can make. And last example here says a combination has 39 numbers on its dial. To open the lock, you must turn the dial right to the first number, left to the second number, and then back to the right for the third number. So there are 3 different number combinations for this lock. So we have the first number, the second number, and the third number. And I need to figure out how many different lock combinations are really possible. So here, if I look at this particular example, for the first number, I have 39 number options. For the second number, I have 39 number options. And for the third number, I have 39 number options. So for this counting principle problem, we actually have 3 numbers being multiplied together that are the exact same because we have 39 options for each. So we have 39 times 39 times 39 for a total of 59,319 different combinations. So just by having 39 options for each number, we were able to create a large number of combinations for that 3 combination lock.